Capacitor, you might ask. Well, a capacitor stores electrical energy within a circuit. You can calculate the capacitance using C equals Q over V. Capacitance is measured in farads. Yep, that's right, you guessed it. It's named after this guy, Michael Faraday. Remember him from high school? Yeah, neither. And also, capacitors only work in AC circuits. In a DC circuit, they act as an open circuit. What is an inductor, you may also ask? Inductors can generate electromotive force in a circuit. You can calculate inductance using L equals the permeability constant times n to the power of 2 times A, and all of that over little l. The unit of measurement of inductance are henries, and you guessed it, named after Joseph Henry. And unlike Faraday, I don't actually know who this is. And finally, again, like capacitors, inductors only have an effect in AC circuits, not DC. Reactance in an AC circuit is often compared to resistance in a DC circuit. The primary difference between the two is that reactance is dependent on frequency. The equation XL equals 2 pi FL and XC equals 1 over 2 pi FL shows this. Both of those equations include frequency, whereas in Ohm's law, V equals IR, frequency is not included. Another thing to note is that when frequency increases, so does inductance, whereas the reactance decreases. And then, when frequency decreases, so does inductance, whereas reactance increases. Another important thing to note is that capacitors and inductors create a phase difference between the current and voltage. For a perfect capacitor, the voltage lags behind the current by 90 degrees, and for a perfect inductor, the current lags behind the voltage also by 90 degrees. This graph here shows the voltage lagging behind the current, so it is for a capacitor. For an inductor, they just switch around. Alright, here I am calculating the reactant across the capacitor. So you have a capacitor drawn, 1000 Hz, 100 ohm resistor, and 0.75 millifarads in the capacitor. So I'm using the XC equals 1 over 2 pi SC formula. As you can see, you put it in, you get 212.21 ohms. Okay, now I'm going to show you how to calculate the reactance across an inductor. So I've got a little circuit here, 1000 Hz again, 100 ohm resistor, and a 10 millihenry inductor. I'm using the XL equals 2 pi FL formula. So you chuck your units in, and it spits out 62.83 ohms. I hope that video was informative and more importantly funny. Cheers.